Kia ora Year 11 and 12. This is going to be a short video going through the starter I did in class yesterday with my class. So what I'm going to do first of all, just to keep it really short, is I'm just going to delete that second question there. We're not going to look at that right now. So what we've got here is a function, which is a cubic, given by this equation. And the question is, can you find the equation of the tangent parallel to the line passing through both A and B? So this is point A and this is point B. So A is the point 22 and B is the point 58. So what we're looking for is a line that is parallel to the one going through A and B. So there's A and B, and we're looking for a tangent to the curve with the same slope. So the first thing we probably want to do is to figure out the slope between A and B, and that's going to be rise over run, so 8 minus 2 over 5 minus 2, which is 6 over 3, which is 2. So we're looking for a line that is tangent to that curve with that slope. Now, as it turns out in this case, the line AB itself is just touching the curve there. So we can see that that's going to be our first solution. But now we want to work out, if we look at all the lines parallel to that, is there another one that's also going to be tangent? And we can see that there is, and it looks like it's going to be around here. But we need to show that using calculus. So that's what we're going to do next. So step 1 is to figure out the gradient through A and B, and we've done that. We found that m was 2. The next thing is to figure out where will the tangent have that gradient. So there's two parts to this bit. We know that the gradient function will tell me the slope of the function, or gradient of the function, for any x value. So to get that, we have to differentiate, and we get 6x squared minus 36x plus 50. Now we want to work out where will this gradient equal 2. So we're going to solve 2 equals 6x squared minus 36x plus 50. Don't reach for your graphics calculators, because this is a really easy quadratic. So it's going to be that. Divide through the common factor of 6, and we get x squared minus 6x plus 8. So washing up to the top here, I can factorise that, and I'll get x minus 4, x minus 2 equals 0. So I have two solutions, x equals 2 and x equals 4. Now that's what we saw from looking at the graph anyway. What we have to do now is to find the matching y coordinate and then get the equation of each tangent line. Okay, so the slope here is 2. We've done this bit. What's the gradient through AB? And then where's the tangent going to have that gradient? Okay, so we've found our 2 points, x minus 2 and x minus 4. Right, now the next thing we have to do is to get the y coordinate. So f of 2 is going to be, well, we can do all of this stuff here by putting it back in the function, but there's a smarter way to do this. I'll do this the silly way first. So this is what we would usually do. Substitute in 2 and work it out. And there we go, we get 2. But we actually already knew that, because we know that the point on the curve where x is equal to 2 is A, and A has coordinates 2, 2. Right? But now we've got this point, and we know the gradient is 2, so the equation of the line will be y minus y1 equals m times x minus x1. So everything's a 2 in here. Y minus 2 is equal to 2 times x minus 2. Y minus 2 equals 2x minus 4. Right, and once we take this 2 to the other side, we get this for the answer. The equation is y equals 2x minus 2. We do the same thing when x equals 4. Right, we figure out the value of the function at 4, and that turns out to be negative 2. Now I'm not going to go through all of that working. I think you should be able to do that substituting for yourself by now. Same thing again, we use our equation for a straight line with the point and the slope, and we get 2x minus 10. So this is just putting this all back together on the graph. We can see what we've drawn here. are our two tangent lines. So that one is equal to y equals 2x minus 2. And this one here is y equals 2x minus 10. So it's just touching the curve and it's parallel to the line through AB. Okay, you might want to practice that question with some different functions. Maybe try doing it with a parabola and see how many solutions you get, or you could try doing it with a different kind of cubic. Thanks for watching, and let me know if there were any problems with the video.